So these extension notes that we're doing, everybody should be on page 656 in their books. And we're first going to decide what does the rate of change mean, or how are we going to find it. So anybody see in the book where what it tells us we're going to do to get our rate of change?
The amount of change in dependent variable to the amount of change in independent variable.
Yeah, so we're going to look for the change in the dependent variable. So there's such a long line there in our fraction. And typically, the dependent variable is represented by which variable? X. Yeah. Y. It's actually the Y value. So our rate of change, another thing we could say is we're going to have our Y value. We're going to find how much does the change between the Y values over the change in what? Independent variable. Back when we worked with linear functions, we talked about rates of change. In a linear function, you have a constant rate of change. In a nonlinear function, you have a changing rate of change. So between any 2 points, it doesn't necessarily stay the same. And our independent variable is x, so we're going to find how much does it change between the x's. So our y's need to be represented upstairs, and our x's need to be represented downstairs. Or in other words, an example of a rate of change would be how much you get paid per hour. So if you make $8 per hour at your job, that's a rate of change. You get $8 for every 1 hour. That's a rate of change. When you're driving your vehicle, and that's supposed to go over 25 miles per hour in a residential zone in Valley City, 25 miles per hour is a rate of change. Okay, so let's look at number 1A here, where it wants us to determine, we're at the very bottom of the page, so check it out problem, the bottom of page 656. Determine whether each function has a constant or variable rate of change. Constant means it will always be the same. Variable means it's going to vary, it's going to change, okay? So we're going to look for, we have this set of ordered pairs, and remember how it's a lot easier to determine the changes or what's going on when we put it in a table? So let's write these first of all in table form. So would you transfer those ordered pairs down into the table that I've provided there for you? Okay. First thing we're gonna figure out here is we need to do the change on both sides. So let's just start on the left. What happens when you go from negative? And we're always going to be adding or subtracting here, you guys. Okay. So what happens when we go from -3 to 0? Caitlin? Plus 3. 0 to 1? Plus 1. Okay, let's go ahead and finish that. What's it changing? What are the changes in x? And then what are the changes in the y's? So what's that first change in the y? -3. It's going down 3. Okay, now what we would have said right now at this point, if we were doing this and we were trying to determine what kind of a model it was, we were trying to determine if it was linear or not, we would say it is or it isn't linear. It's not, because we're not seeing a constant change in x while there's also a constant change going on in y. Here's the difference. Here's why we're not. Because they left out some x's in there. So let's look at how we're going to check it out is by doing rate of change. The change in the, remember it says up here, change in the dependent variable over the change in the independent variable, or in other words, take that change that you got and put it, the change you got for the y, and put it over the change you got for the x. put that change you got for the y and put it over the change you got for the x. So let's go do that down here, in this spot where I have. Let's take our first one right here. So we're really doing this right here. We're concentrating on that one. We're going to put the change in the y, which is -3, over the change in the x, which is +3, and we're going to divide it out. What does that divide out to? -1, -1. So the next one is we're moving on to the next change. We have a change in y is -1. The change in x is +1. What does that divide out to? -1. But we have to do it for all of them. We have to make sure it stays consistent before we can decide if it is a constant rate of change or if it's a variable rate of change. So now let's move on to our next one, which is a -3 over a +3. And remember, change in y, get that planted up here, change in y over change in x, just like in slope. Y is upstairs, rise. X is downstairs, run. So -3 divided by +3, well, we already did that down at the end, it's -1. And ditto, we have the same thing again. -3, the change in y over the change in x, and we get -1 again. So we would say this function has what kind of rate of change? A constant or a variable? This one has a constant. And if it has a constant rate of change, it's actually what kind of a function then? What do we know already? If it has a constant rate of change, what kind of a function is it then? Or in other words, if we graph these ordered pairs, what kind of a graph would we get?
Linear.
A linear, yeah. If it's a constant rate of change, even though I know where you're stuck right now, I get what your brain is trying to say. Wait a minute, Mrs. LeGrand, you said if we don't have a constant change in x while we have a constant change in y, then it's not linear. But that's when we have a table of values where there's not, the jumping around from x's goes. We have that constant change in x. Here, because we don't have a constant change in x, we still get to check it out and see if it's linear. We don't stop. We say, oh, it still could be linear by checking to see if it has a constant rate of change. We'll check the change in y's and then compare it that way. So I get where you might want to say, oh, well, wait a minute, it's not looking like it's supposed to when we're looking for a pattern. We're actually doing a pattern thing right here. We're looking to see if that pattern really holds true when we start dividing. Okay, let's do our next one. Put them into the table first. They're a lot easier to work with in a table than they are in a horizontal list. Trust me on that. And then find the changes in x and the changes in y. Do that on your own.
So like when you do the rates of change, y always goes on top, right?
Yep, after you get those changes, yep. So down here when you start putting it into this spot, you're saying? And then compare with me and see if you agree with the changes we get in the x's and in the y's. And then start setting up your y over x changes. And then we'll decide if we have a constant rate of change or a variable rate of change. I get two of my rates of change, the first two are 2's, and my last two are 1's. Did you get the same thing? Okay, so what are we going to say? What kind of rate of change does it have? It's a variable rate of change. So it's not linear. We don't know what it is, but it's not linear. Okay, any questions about how to do these? What you're going to know. Okay, then you've discovered there's more pages, haven't you? Okay, let's move over to the second check it out problem at the bottom of page 657. It says, use rates of change to determine whether each function is linear or nonlinear. Oh, are we just talking about different words but really the same thing? Guys, if we have a constant rate of change, what is it? Help me. If we have a constant rate of change, is it linear or nonlinear? It's linear. If we have a variable rate of change, is it linear or nonlinear? Nonlinear. So we're still doing the same thing, you guys. So let's just take our table that they had there in the book and let's get it written in. You wrote yours in wrong. I did write it in wrong. This should be a 16, shouldn't it? Yeah. Okay. So I gotta change this one down here to being n plus 8. Okay. No need to get freaked out over fractions because it's going to turn out pretty decent anyway. Change in y over change in x.
I just took, I didn't multiply.
No multiplying going on here.
It's for exponential.
So we find the changes in x, so find the changes in y, then we take that change in y with the corresponding change in x, put them over, put the y change over the x change and divide it out. Well, anything over 1 is itself, isn't it? So what is 1/4 over 1? 1/4. 1/4. Next one is 1/2 for the y change over 1. What's 1/2 over 1? 1/2. Next one is 7 over 3.
2.5.
That's not 2 1/2.
2 1/3.
No, it's not. It's 2 1/3, isn't it? Yeah. So, and 8 over 1 is 8. Constant rate of change?
No.
What kind of rate of change? Variable. So the function has a variable rate of change. And this time we're saying then, is it linear or nonlinear? Nonlinear. If it has a variable rate of change, it's non-linear. Okay, so 2b. If you haven't started it and you're done with 2a, go ahead and start 2b. If you're not done with 2a, you need to finish that one up. If I can copy it right this time. So does anybody need 2a? Come on. set up your rates of change. What are the rates of change? All of them? Yeah, when we're dividing into zero, that's when it's on the top, we're dividing into zero, or zero divided by something other than itself. You will always get zero. So, can we have a zero rate of change, do you think? Yeah, so it's still a constant rate of change, isn't it? It's constant zero. Give me an example of no change. Zero rate of change.
0 on both sides.
Zero on both sides of the table.
Yeah, like both x and y.
But then we have the, because then we have a zero over a zero, and what would happen? Can we divide by zero? Give me a real life example of something when there's no change. Or something close to being no change.
Would be like a life example.
Yeah, like example of something where the rate of change remains constant. Remember I said there's some of you
Seconds in a minute.
okay, so there's always
60
60 seconds in 1 minute, that's a constant.
24 hours in a day.
24 hours in a day. How about your job?
That changed a lot.
Yeah, but until you get a raise, do you get paid the same thing per hour? Not talking about your paycheck, talking about your rate per hour.
Yeah,
Did it be like the height of the building?
That
That would
wouldn't change. But
Well, if they're
you gotta
building.
compare it to something. Rate of change is comparing things.
the
So
height
let's-
of the building over time, years.
Yeah, I feel like
Yeah, I
the
suppose you could say the height of the building remains this, you know.
hospital in Fargo, that's a rate of change. It's going up.
Yeah, there's a rate of change, but is that remaining constant?
No.
If it was, they wouldn't be getting anywhere, right?
No.
Yeah. Okay. So is this linear or non-linear?
linear.
It is linear. In fact, what kind of a line would this be? No
Straight.
change. Well, it's a straight line, but what kind of a straight line? No change. Think of no change.
It'd be like a horizontal.
It'd be a horizontal line, absolutely. Yeah, it'd be a horizontal line. No change going on. Okay? Okay, let's go on to what do we have left to do? Number 3. Okay. So we're in the check it out problem in the middle of the page, number 3. Rika and Charlotte, I'm going to say it's Rika, I don't really know, but each invest $500. Each month, Charlotte's investment grows by $25, while Rika's investment grows by 5% of the previous month. Identify the function that gives each investment as linear or nonlinear, and who is earning money more quickly between month 3 and month 4. Okay, so notice I've got some stuff set up here for us, but first of all, we got to decide what's X going to represent?
The months.
The number of months, okay? Because you always have to decide what makes more sense, to say hours per mile or miles per hour. Does it make more sense to say dollars per hour or hours per dollar? Does it make more sense to say months? Let's see what the Y would represent here. What's the Y represent?
Income.
So total dollars, right? Okay. So let me see how I just wrote it in the notes so it can be comparable. Yeah, total dollar amount. And why is it important to decide which one is going to be X and which one's going to be Y? Because in rates of change, they have a label. And remember, this is our Y, we're saying, and this is our X. Okay, well, does it make more sense than, remember, in rate of change, we have Y's upstairs and we have X's downstairs. So does it make more sense to say dollars per month? Or does it make more sense to say months per dollar? Dollars per month. So I think we've made a good choice here. Y's go upstairs, dollars upstairs, months downstairs. Dollars per month. Okay, so then let's figure out Charlotte. What's happening with Charlotte? She's got $500 in there to start with, right? So when X is equal to 0, Y is 500. Okay, what does Charlotte do?
Add 25 each month.
Adds 25 every month. So how much would she have in month, after month one?
525.
She'd have 525. So we just keep adding $25, right? So we're making our own table this time. We weren't given any ordered pairs, we're just making some. And then we are going to do exactly what we've just been doing. We're going to say, okay, what's the change? What's a change by? Which of course should make sense because we, especially in the Y's, that's what we just did to get all those, is we added 25, didn't we? Okay, so between months 0 and 1, we put 25 over 1, and we're going to get 25. Between months 1 and 2, 25 over 1. Kind of redundant here, isn't it? Is that going to be our rate of change every time? Yeah, that's going to be our setup every time. So what kind of a function do we have here?
Constant.
We have a constant, we could say this is a constant rate of change. Let's do that over here. We have a constant rate of change. If we have a constant rate of change, does that say we have a linear or a non-linear function? That's linear then. Okay, so there's Charlotte's. Let's do Rika now. How much did Rika start with? $500. Okay, so $500 for Rika. What happens with Rika?
Investment grows by 5% of the previous month's amount.
Oh, investment grows by 5% of previous month's investment. So what are we going to do?
Take 500 0.05.
Okay, so do that. Okay, take 500 times 0.05.
25.
That's how much it grows by. So how much money will she have in her account after month 1?
200 or 500.
$525. So in other words, we took 500 times 0.05 and we got 25. So we say 25 plus 500. That's how we got our 525 here. Okay? Now what do we do? To get the next one.
Each month.
So it grows by 5% of the previous month. So don't we take 5% of 525 now? So now take 5% of $525. And it's probably going to come up to some, like some cents or something, but let's round to the nearest dollar. So what's 5% of 525? $26?
It should be 5.25.
Okay, so we're going to round to the nearest dollar, so that's $26. So we're going to add 26 to 525.
551.
551. So what we did is we took the 525 now times 0.05. We got 26 and we added that to 525. By the next amount. How much is going to be in there? You guys do it. It's going to be in there at the end of month 3. Do it, Brian. I know it's going to do it for you. You're not going to get just right at the end. 5% growth at the end. I'm sorry, what?
Yeah, that's
We had that, because you would round to the nearest dollar. Just round it to the nearest dollar. And you should have gotten $28. And then we add $28 to 551.
I was like, what are you talking about?
I'm talking about the 5%,
oh yeah.
right? Okay. And then we have one last one to do, 579 now times our 0.05. And whatever that comes to, we add it to our 579. And we will be able to say how much is in the account after 4 months. Okay, so let's do our, what are the changes in X and the changes in Y? So the X is changed by what? 1, all of them changed by 1. First set of Y's changed by 25. Second changed by 26. Third changes by 28. Fourth changes by 29. Do you think we have a linear function? Probably not, because when we do our change in Y over our change in X for the first between month 0 and 1, that equals 25. Between months 1 and 2, we get 26. Between months 2 and 3, we get 28. And between months 3 and 4, we get 29. Now, you're probably thinking this just seems crazy, but the only reason that we do a lot of repeating here is because our change in X is going by 1. It doesn't always go by 1. So we have a variable rate of change here. We have a variable one, not a constant.
So it's not linear.
So it's non-linear. You know that, can anybody tell me what kind of non-linear function that you can represent? It keeps growing by 5%. Rita's is what? Exponential. It's exponential. If you divided those, like 608 by 579, and then you divided 579 by 551, and then you did 551 divided by 525, and then you did 525 divided by 500, they should all be really, we did some rounding in here, but they should all really round to 0.05, which is 5%. Okay, so who's earning more money quickly between months 3 and 4? Rika is. And she's earning approximately how much more?
$8 more.
Between months 3 and 4, then Charlotte.
I just subtracted 600.
More. Okay, so how much money is in Charlotte's account between months 3 and 4? 25. She earned $25 more. How much did Rika earn? 29. So we really do 29 take away 25, which is $4 more. Okay, so this is the kind of thing that you're doing in that homework, 1 through 8, 22, and 23. So get out a sheet of loose leaf paper.